It's my honor to present to you the 2026 Daniel C. Jackling Award winner. Ralph J. Stegen is the recipient of this year's award, and he's receiving it for distinguished achievement in exploration geology, resource development, and ore reserve additions. Ralph retired from Freeport-McMoRan as Vice President of Mine Site Exploration, having responsibility and management for all exploration and resource modeling functions with Phelps Dodge. Then Freeport's operating and non-operating mine sites in North and South America. He has over 45 years of experience focused on porphyry copper and molybdenum, carbonate-hosted replacement, IOCG, and I said, Ralph, what's IOCG? And he said, iron ore, copper, and gold. I said, oh, okay. And veins. His early career was in many classic districts in the western United States, including Park City, Tintic, Marysville, Goldstrike districts in Utah, the Leadville, Gilman, Aspen, Alma, Mount Emmons, and Breckenridge deposits in Colorado, in New Mexico at Cuesta, Nevada at, excuse me, Pioche and Eureka, and in Butte, Montana. He started in 1991 with Phelps Dodge at Morenci. Then he was transferred to Tyrone. He returned to Morenci as chief geologist, and in 2001 as an exploration vice president based in Tucson. Since his retirement, he's been working on manuscripts and is also doing some consulting work. So I introduce to you Ralph J. Stegen.
I'd like to thank Bob for the introduction and also the M&E division for receiving this prestigious award. As a Utah native, it's particularly gratifying for me to receive the award in Salt Lake, not far from Bingham, and actually within a mile of where Daniel Jackling lived on South Temple. So, to start things off, this is a photo of Morenci prior to the open pit. And the outline of what was termed the clay ore body is that white line there. So to move along, this is the outline of the presentation. I'll be talking about history of porphyry copper exploration, touch briefly on some of the classic statistics, talk a little bit about Henry Krumb. Some of you might not be aware of his contributions, what the USGS has done, their work in describing and characterizing some of these important districts. Moving on to the 50s through the 2000s, exploration methods. Two pretty important people that found a lot of copper, David Lowell and Jip-Bob Moffett. And then quickly do some case study things about which I was and some of the people I worked with were involved with. So this is a pre-open pit map of the Bingham district. It's from a professional paper by John Valwell, published in 1905. Pointer doesn't work. Oh, there. So Bingham Canyon is right here. This is the Bingham stock, the ochre formation of the host rock that the intrusion wasn't placed in. And then this is another map that shows the distribution of the mineralization types. So there were some early gold placers, some underground mining of copper, gold ores in green, and then an outer halo of silver, lead, zinc. The area that was of interest I'll show in this next figure, and it's the upper exposure, it's exposures of the Bingham stock that contain some hematitic leach capping, or the sign that there were sulfides there, and also trace amounts of malachite and azurite. I mean, Creek-Kennecott, excuse me. So this is a map of the canyon. Okay, I'm gonna have to wing it. So anyway, an early prospector named Enos Wall recognized in traveling that there was some signs of what would be some copper mineralization, and he drove a series of adits, and you can see the adits. There were nine of them, and you can't read the assays, but what I've done is I put on here the trace of where these adits are, and I've grouped them in terms of what sort of grades that they had, and you can see the red was grades between 1.5% to 2% copper. These are rib samples from the drifts, and the purple are assays that in excess of 2%. So there was widespread indications of a pretty high-grade copper mineralization. Well, this got the attention of Daniel Jackling, who subsequently acquired these claims. And with the work of Gamble and actually Henry Krumb did an extensive amount of drifts and raising, doing some samples to sample and characterize the ore, but also drilled some churn holes. And these turned out to be pretty important in some layer work. And from that delineated this mass here that, according to Parsons, contained about 12.5 million tons, averaging about 2%. This is some early maps of the Morenci district. It's in southeast Arizona. Early mining started with some oxide copper, very high-grade deposits, similar to what was mined in the early Bisbee days. Here, exploration essentially consisted of them just following the ore. Some later prospectors opens up some mines, and the Detroit mine was the first use of drill holes that I'm aware of in Arizona. I don't know if that's right or not, but the significance of that, they drilled down a dike and encountered some significant amount of chalcocite. So before it was all oxide, well, down lower they found chalcocite, which indicated the presence of that and the potential. So they went, as these early miners drove these long adits. There's one here. This is the clay tunnel. This adit encountered 425 feet of 3% as chalcocite. So that drove a lot of the drifting, raises, subsequent mine plans. And from this blue area, they mined 43 million tons of about 3%, all from the underground. So as this was phasing down, where do we go next? What's the next step? So they were aware of some earlier assays, but the trouble that they had, it was a meager 1%. And if you're used to mining the high grade, that's quite a hit. So there was a lot of work done, a lot of churn drilling was in this area, and resulted in what became the clay ore body, which had a reserve announcement of about 260 million tons of 1%. Containing about 5.5 billion pounds of copper. Phelps Dodge studied this for 10 years. And it was pretty interesting because they brought a CEO in, his name was Louis Cates. He had actually worked for Jackling at Bingham, and he was a very forceful guy. And he was instrumental in a large part in making the decision to pursue open pit stripping and mining at Morenci. So Henry Krumb, he worked with Robert Gamble and Jackling in the early days of delineating the Bingham deposit. And he's interesting because he's the first to develop what was a grid drilling and detailed sampling program using churn holes. And he was a stickler for QA, QC, he did all of this stuff. and it resulted in what was called the Krumb technique. And it was a method in practice used to delineate porphyry copper deposits for reserves. So it was a polygonal-based estimate. But what did this do? Well, it significantly decreased the time to delineate an ore body out. If you think about churn drilling versus all the drifting and raising, it can be a long amount of time savings. He established a consulting firm, did some early work in the Miami district, and recommended that the inspiration deposit to William Boyce Thompson of Newmont fame. And he also worked extensively again at Bingham, Ely, Ray, El Teniente, Inspiration, and Tocopala. The work that he did that resulted into a large part of the reserves, most of which were mined underground. In the later part of his career, he established the Henry Krumb School of Mines at Columbia. So one of the other interesting things was the mining law of 1872. I'm not going to read all of these things, but basically what the law did, it provided a springboard for an enormous amount of litigation between two rival mining claims. And in this case, this is an example from a book that Reno Sales wrote, where you have Anaconda on both sides surrounded by a claim. These vertical lines show the limits of the claims that were held by a guy by the name of Augustus Hinsey. So the question is that we can follow the veins here, but then there's this nasty thing called a fault. So what happens to the veins on the other side of the fault? Well, the prize was this horsetail zone, and you can see there's discrete veins here, but it's not so discrete here. So there was a lot of work done by Anaconda, and the work consisted of geologists and engineers to unravel the character of these veins. Hinsey took a much different approach. He hired 37 lawyers and thought that the vein goes like this. So who do you think won that case? Well, it wasn't really resolved. It ended up that Anaconda purchased the claims from Hinsey. But what came out of that? They hired a lot of high-powered consultants who really did a lot of work and unraveled a lot about the characteristics of veins, porphyry systems that we used in exploration elsewhere. The methods and procedures of underground mine mapping were developed as part of this program that previously had not ever been done. And what ultimately really happened, it resulted in district consolidation, where mine plans, operating plans could be optimized, and it resulted in an increase in the production. So another real important facet that drove exploration was the work by the USGS, where they documented and characterized the geology and the mineralization of a lot of these major districts. And they provided maps, cross-sections, very good descriptions that were used by industry and mining engineers to exploit the resource. The early things were basically focused on veins, and you can see some of the classic places here. Some carbonate replaced it. But they also moved on to some classic porphyry systems, Bisbee, Bingham, Morenci, Butte, Robinson, classic paper by Ransom. These really were important and very useful descriptions that previously had not ever been done. And it built on the knowledge base where you could go and look for rocks and use that information to find more deposits. So with a large part of the work that Anaconda was doing, they realized the need to establish geology departments and exploration groups. So one of the early ones was Anaconda, where Reno Sales was instrumental. Vin Perry, John Hunt, but they focused on deposits and districts, did fabulous and meticulous work. And what did they get out of this? More stuff at Butte, Chucky, El Salvador, Cananea, Yarrington, Twin Buttes, big stuff, found some big stuff. Bear Creek and Kennecott also established one. So they were regarded, I've heard, as one of the first worldwide exploration firms that looked for porphyry copper deposits. Really looked at detailed work, particularly at Bingham. Santa Rita did a lot of work that really advanced this science. And look at some of these. Bingham, they called it Braden, Santa Rita, Ray, Robinson, and Lone Star, which they discovered in 1955 in the Safford District. ASARCO, Kenyon Richard, Harold Courtwright, they were masters of interpretation of lead cap. You can read some of the things that they found. But also important were the published literature that documented these things that previously wasn't that well known. The work by Sales on the Veins, Hunt, which describes some of the early zoning in Bingham that was probably still valid, a lot of his concepts, Augustus Locke on lead caps. Of course, the important textbook on mineral deposits by Lindgren in 33. And a lesser known thing were a series of International Geological Congress guidebooks published in 1933, and those were a valuable resource and description. Excuse me, I need a drink first. So moving on to the 50s, this is a figure from Siloto and Thompson that shows discoveries from 1970 through 2005. There were 78 of them. And he separated, how did they find them? The top part, the large part, was directly related to geological field work. Geochemistry played a big role, and you can see the role of geophysics, serendipity, drilling. But really, it's sort of an evolution, and you can read this, I don't mean to go through all of this, but heavy field work early on, leach capping, appraisals, some publications of Lowell and Gilbert came out with a model in 1970 that was still used today in some form, some important text all the way down. So now you look at, well, what are we doing now? Well, a lot of it is related to revisiting old districts. In Arizona, that's the role of extension, cover rocks, dismembering porphyry systems. It's really, I think, an important tool, because if you look at the amount of covered rocks in Arizona, it might comprise 70% of the landscape. And are people using AAI? I think some are. So that brings me to David Lowell. He lived in southern Arizona near the Mexican border, but he was a very principled man. Those of you who knew him, he was a strong advocate of field work. He was a big advocate of drilling, but you need to know the target, and he didn't like to have people looking over his shoulder and sort of hounding him on how to do stuff. And his list of discoveries are significant. Jim Bob Moffett. He was chairman of the board for Freeport. Rich Lavelle and I got to work with him rather closely and would agree with all of these. He was a wildcatter, an entrepreneur, a maverick, a risk taker, a big personality. And he formed Freeport in 1981. Under his leadership, he was involved in the Grasberg discovery, acquired Phelps Dodge in 2007, and was an ardent believer that immense amount of value was added through exploration. And he actually said this a lot. He actually put it on ball caps and would wear it around a lot. I mean, that's just the kind of guy he was. But under his tenure, Rich and I working directly with him in the Tucson office. It was the golden days of my career in terms of funding and support at a very high level. So what is brownfields exploration? You know, in my view, it's a pretty simple task. Replace and add reserves in an existing mine site. There's usually abundance of data. You can read this. Rich talked about this with his talk. But it can often be of variable quality. Historic maps, maybe they might be mined out. Individual rock types are grouped. The churn drill logs aren't very good. I mean, these are the data that you have to live with and try to work through. And then for newer sites, you have more core, use of block models. You've got an idea of the rock types, alteration. This was a common sort of an environment, and a key part of working with these big mines is you've got to have positive relationships with the operations group. They need to, you're adhering to the safety, your drilling crews are on safety things. All of this is coordinated under a positive way that you each have a job to do, and that's a big part of working in a mine is you've got to work with the operations group. And some of them are in places, like that's a drill rig, right on the top of this hill. That was an area that used to exist north of the Morenci pit. The safety people were all over. Are the berms high enough? Do you have the right kind of things? All these sort of things matter, and you got to pay attention. So this is the only rock shots I'm going to hold, but this is kind of an important thing because what do you use to find this stuff? Well, the most important thing I think you can do in an established district, what are the paradigms? Oftentimes it was driven by maybe a strong personality chief geologist, or somebody had an idea that there's no ore over here, or that's a post-ore rock, or all these sort of things. They need to be challenged, because that's where the opportunity is. And so oftentimes you use drill holes, make a lot of block models, but you can use those block models to create shapes at some cutoff value, and the shapes are wonderful tools because section to section, most people kind of lose track of what happened 5 sections ago, but this allows you to turn things around and look at all these things and realize opportunities that might not have been recognized, grade shells, metals, zoning. But one of the biggest things is what's the cross-cutting relationships? And so this upper one is this pointer sort of works and it doesn't work. Anyway, on the right side of the thing, you'll see there's a myriad of quartz veins. That's from a stock that formed one of the upper ore body at climax. And then next to that, it's cut right here. So this is the quartz veins. It's cut by this dike, which is in turn cut by a quartz moly vein. So what does that indicate? Well, there was a moly system developed in this stock. It was cut by this dike that was related to a stock at depth. That in turn has moly in it, and this was the dike relationship where they used to find the lower ore body. This is one from Morenci that I think is pretty interesting. This is a sample of 2 intrusions, monzonite, but notice these are quartz biotite chalcopyrite veinlets. So this indicates to me there was a stock in place, a hydrothermal system formed, and then it was cut by this other rock, major stock, which is in turn veined by quartz, moly, and some chalcopyrite veinlets. So in this sample, there's pretty clear evidence of 2 stocks and 2 hydrothermal systems. So this is a map of the Morenci district, greatly simplified basically there's two stalks. There's the monzonite down here, and this purple one is the other stalk, the older granite porphyry. So, you know, we use terms like hypogene and supergene. Well, Emmons actually made a definition of those. Hypogene is primary, formed up down, supergene, secondary, or formed above. The thing that was important at the time was Morenci was a huge SXE to W operation. So as an exploration group, you needed to find more SXEW leachable type material to keep the behemoth full and to replace those pounds. So exploration was focused. Steve Enders was involved with a lot of this. I was involved with. There's a lot of people here that understand that, and it was a huge driver and a lot of pressure to find more. When you're mining the tonnages that they were doing and doing their production at the time. So to illustrate some of this is a cross-section through the clay pit, the Morenci pit. This was done by Rick Priest in the late 1980s. The pit at the time is this outline here. Basically, it exploited this large chalcocite deposit. So that was contained within this monzonite porphyry stock cut by this fault. These are Paleozoic rocks that induce these odd shapes. But the thing that's interesting is all the drill holes stopped at the bottom of the enrichment. Well, why is that? Well, the grade went from 0.5, 0.4 to 0.1. There was no grade in a lot of this stuff, except a lower zone that had a concentration of 0.3, that's chalcopyrite. Well, what's that? I mean, that was kind of interesting, because everybody thought there wasn't really any hypogene potential at Morenci. Some people thought there was, and these were sort of ongoing thoughts. And so we were looking at that and said, well, where else in the district do we know this? So that slide was right here. There was another zone between two large deposits, Western Copper and Morenci, which also bridges the contact between these two stocks, the western part of the Coronado pit and along Garfield. So we looked at this. David Parker and I looked at some wide-spaced, deep drill holes. So these are 6,000 footers that we placed to test the potential around the stock. Not all of them hit, but you got to find out, like Jim Bob just to say, where it isn't. And so what did that result in? Well, this is a map that shows, you can see there's sort of a circular line of hypogene, that's in red, that's with grades above 0.2. The moly is the purple. The oxide, which is the supergene in situ oxidation of what was chalcopyrite, that forms this huge ring. An interpretation of that is this. So Morenci isn't a deposit, it's a cluster of three. And you can see the overprinting of these. So the other thing that's interesting, if we're looking at this, if you look at other deposits, an ore shell, as we call it, or a copper shell, usually has a form of an inverted cup that is atop the intrusion. Well, this has been eroded pretty deep into the system. So what happened to the stuff above? Well, one interpretation, it was leached, and the copper that was leached went down and enriched the hypogene to form the immense chalcocite deposits that was characterized the district. But I also think a lot of it left the system. So we're looking at a truncated Morenci, so you think if that was in place, how big could that really have ever been? So next I'm going to move on to resolution. That's big deposit between Phoenix and Globe. At the time it was owned by Magma. And here's some history. This is 9 shaft. The thing to note here is this drift. Scott Mansky was assigned this project to do some detailed mapping of these drifts. And, you know, it's in these Cretaceous rocks, and he noted that there were some alterations, systematics that indicated the presence of something maybe to the south, but didn't really know. Drilled a horizontal hole, intersected 460 meters of 0.6. Not bad, that's pretty good. So what was that? That was bornite veins, a myriad of bornite veins, anastomosing set of those, and so they followed up with some subsequent things that continued to drill these significant intercepts. Well, that got the attention where they couldn't drill us anymore from there because of space problems, so they did a lot of drilling from the surface. And this is probably out of date, but it gives you at least an idea. As of 2002, about 1.8 billion tons of 1.5%. And this is the last one, Cerro Verde, Santa Rosa. It's near Arequipa, southern part of Peru. Historically, it was a deposit that was run by, it was nationalized by the Peruvian government, and they did some SX work on some oxide copper, hence the nameplate. And it was really a supergene focused thing, and there wasn't a lot of drilling. So this was we did some early drilling. This is the 2100 level, so that would be about here. And one of the things we looked at is the distribution of drill holes, and noticed that, well, is there a circular pattern to these, and could these be early indications of what could be an ore shell? Tested that hypothesis, drilled some deep holes, and in fact it came through. So we worked on these things. A lot of this was done by Luis Tejada. He was the chief geologist there. Great job. And it resulted in the identification of two separate porphyry systems, Cerro Verde, Santa Rosa, and this is a map. These white things are younger igneous rocks that cut through the copper shells, but there's something here and there's something here, and it's better defined here. You can see a shell here around Santa Rosa, another shell around Cerro Verde, and this is the silver that's also associated. So I'm not going to go through this, but here's sort of a partial list of some of the brownfield discoveries, extensions, well, whatever you want to call them. It's quite a list. And most of the bigger, so what do you see in common? If it's a big district, stick with it, challenge the paradigms, and oftentimes it'll bear fruit. So, to wrap things up, in my opinion, master's degree is a working degree, that's just me. Economic geology programs, the number of them that offer this are declining. But what is it that they provide? Skilled economic geologists with this sort of a background. It's a plus if they've done a thesis, but most importantly, they need our help. Some of them are looking for funding. The dean's got their eye on them. What sort of resources do you bring in? All these kind of things. I think there are future internships. Funding these students is an important part. But what's the future look like? Well, at high copper and precious metal values, think about the Lurch-Grossman cones that are popping. They're huge. How do you drill these things out? Who's going to drill them out? There are immense amounts of drilling, plus the modeling, plus the assays. We need a qualified group of people that can do that within our lifetimes. I mean, these things take a long time. And then you start adding the critical metals program into this, that's more pressure, more demand for people in our field. And I don't think this, I'm speaking from a geologist's point of view, but I think you could say the same thing for engineers, metallurgists, the whole gamut. So I think, please recognize where we went to school, think about how you can help them, because I think they would really like to see us contribute more. So just to wrap up, I think you need to look at the rocks. That to me is pretty important. Challenge what's been done. There's a lot of opportunity. A lot of times the paradigms are faulty. You need to know what the age relationships are of these systems. You've seen examples where a simple piece of core can be extremely revealing of the potential that might be at depth. Develop multiple lines of evidence for every target. The more lines of evidence you can demonstrate, probably the greater likelihood that that target's going to come in. Be an effective communicator. Oftentimes, if you work at a mine, you have to communicate a target and request a budget, oftentimes to people who are not geologists, so you need to learn to speak their language and be an effective communicator. And strive to develop the products that other groups want. That could be engineering, metallurgy, slopes, operational things. The more products that you provide, the more value you're adding to that operation. So, first off, I want to recognize my wife, Kathy, my son, Andrew, and his partner, Annabelle, for being there and to support me. But this is a partial list of the people that I was fortunate enough to work with. Probably missed some people that wasn't by any design, but the people comprising this list, they're geologists, engineers, metallurgists, operators. Those are the people you have to work with. We can't do it by ourselves. If we want to make a reserve edition, we need a lot of people to be involved. And the more we integrate working with them, I think the better off we're all going to be, and it makes it for a much better product. Thank you.